Hello, I'm Alex from ANDSolution, and this demonstration will show you how to design a small fiber to the home network using microducts and AND. This includes designing the network using microducts, blowing in the fiber, checking the optical budget, and generating the bill of material. I've already loaded a DXF background map which contains some property boundaries, a street name, some house numbers, and I've also created trench point frames that contain addresses. I've also loaded some libraries, and one of them contains a symbol for the OLT. It's just a graphical symbol, it has no preset pins or any functionality, and we're gonna place it on this boundary between the two properties. And AND automatically gives you a cross text and another symbol that you could place, and we're just getting rid of this by right-clicking. Now we're going to turn this symbol into a worksheet by pressing A and confirming the dialog. And now you can just click on the symbol or press S to jump in, and you can also press S to jump back out of the sheet. Now that we have the sheet placed, we will set an address to it by pressing Enter on the sheet. This opens the property dialog. Then we open the location information and set the symbol to have a location. Now we are entering a street name. This is just the same street name as for the other addresses in the same street. And a house number. And you will see that when we confirm the dialog by clicking OK, that the symbol will show that it has the address of Museum Street number 13B. Now that the sheet is in place and has a location information, we'll put down the trenches. If you look, we have the property boundaries here that we can use to put the trench on. And I'm gonna just pick up the trench object from the toolbar and start placing the trench. Now, of course, if you have a suitable DXF map, you could just import this boundary line using the live import, which would then generate the trench automatically. But to show the ease of the manual use of AND, we're just going to do it by hand. Now that the trench is placed, and it can be connected to the OLT. We will create this connection by using a microduct bundle, connecting it to the sheet and then putting it into the trench. Now the microduct bundles are placed in the library under cables. I'm going to take a duct package with 4 microducts, click on the sheet to connect it to the sheet, click on the trench to connect it there, and then move up to the other end of the trench and connect it to the end. We have a helper function in AND which can automatically place cables and other line objects into trenches. You just select the object with the mouse, right click and choose connect cables through trenches from the context menu. This automatically places the object inside the trench. Oh, I think we made a mistake now. There's 5 houses and we took a duct package that has only 4 subducts. So move the mouse on the microduct package, press G to select another package from the group, and we just replace the microduct package with the other one. The next step is placing the ONTs in the houses, and we're going to take a 1 fiber ONT from the library, and to place it nicely we want to align it with the house boundary. Now you can rotate it using R by 90 degrees, or you can use the D and S keys to fine-tune the rotation. Of course, there's also a helper function. You just move the mouse with the object on the boundary of the house and press A to align. Now, instead of doing this for each house, we just copy the object, move the mouse on the object and press N to get a copy of the object onto the mouse, and every time you click, you place down a copy of the object. Now we can deploy our first microduct. Right click the duct package and choose deploy microduct. This opens a dialog where you can choose which color and direction you want to use We're just going to take the first one from the left, and we're going to click down the line point and connect it to the ONT. The little triangle at the bottom of the microduct shows you the feeding direction. Of course, it would be a lot of work to do this manually for hundreds of ONTs, so we will just do a block deployment by control-clicking all the ONTs and selecting them into a block. You can see it contains 4 objects, which are our ONTs. Then right-clicking the duct package again and choosing the block deployment command from the context menu. This will open another dialog where we can choose the feeding direction. We'll just confirm that we want to feed from the left, and this will result in the first 4 available microducts being automatically connected to the entries of the ONTs. Now, in case you want to switch the colors of the deployed microducts, you can click on the microduct and then just select another color which may already be in use, in which case the microducts will just switch places. Now we will blow in the fibers. This is happening from inside the OLT, so just click on the OLT sheet and you will see on the right side a small square. This is the inside of the sheet connection to the duct package. I've moved this away a bit and press the pound key, and the microduct expander gets created, which automatically has the addresses of the other side of the microduct if there's a termination device connected. Now we're going to place a splitter from the library and connect this with a 1 meter single fiber to a signal source. In this case, we're going to use an optical entry exit point, which could be used to link a project to get the signal from another project. In our case, we'll just set up the signal source locally. So place the optical sheet entry exit point, click on it, and add a single signal to the wire there. We're going to use a 1310 nanometer wavelength, a power of 12 dBm, and a 3% channel modulation for this example. Set it to be an optical service, and the signal source is set up for the moment. Next part is to connect the microduct expander with the splitter, and this is the blowing in of the fibers. So just create the connections. We'll take normal fibers, we could have patch cables or something like that set up, but in this case, if you're blowing in the fibers, of course, it's the real fiber cable, so you cannot use a patch. As you can see, this is a process which is rather quick and painless. So to see now the signal itself, just move the mouse on the exit pin of the signal source and press R. In the lower part of the screen you see the result. Do the same for the exit of a splitter and you see the signal. Now if we move with the mouse on the expander and press the W key, it will jump to the termination device. You can see the blinking pin, and if we press R there, we can see the calculation result of the optical power down there. Microducts can basically have 3 different states of planning. One is the virtual state, which is the default. Then there's the planned and the build state. You can easily change this state by just clicking on the microduct and choosing the appropriate option from the drop-down menu. And the graphical difference can be easily seen by the varying line style. The left one is set to be virtual, the middle one is planned, and the right one is built. And of course, the microducts don't have to go 90 degrees from the duct package into the house. You can just draw it like any other line object in AND. The last step for this demonstration is to create the bill of materials by choosing the report option from the material menu. You get the bill of materials dialog. Just click on new from drawing, and depending on the data and the setup that you have, you will get the bill of materials automatically created. This ends our demonstration of how to create a simple fiber to the home network using AND with microducts. We hope you enjoyed your time and hope to see you again.